So this is the first question on the paper. You have logs on both sides of the equation, and to find the solution to any equation involving logs, you must collect all the logs on both sides into a single log before continuing. So using the log rule, we can say log of 4 minus 2x multiplied by 9 minus 3x is equal to log of x plus 1 all squared. Now, to carry on with this, we can now take logs of both, we can raise both sides by the power of e, and we end up with whatever is inside the log, i.e. 4 minus 2x multiplied by 9 minus 3x is equal to x squared plus 2x plus 1. Now, collecting and simplifying on both sides, if you expanded correctly on the left hand side, you would have had 6x squared minus 30x plus 36 is equal to x squared plus 2x plus 1. Collecting on both sides gives you 5x squared minus 32x plus 35 equals 0. Factorizing gives you 5x minus 7 and x minus 5 to give you solutions of x is equal to 5 or 7 over 5. Part 2, similar to the first part, if you look at the answer that they're trying to get you to show, you are using ln, so log base power of e. If you take logs of both sides, you get log of 2 to the x e to the 3x plus 1 is equal to log of 10. I can use log rules to separate whatever is on the left hand side of my equation to give me log of 2 to the x plus log of e to the 3x plus 1 is equal to log base 10. Using my log rules again, I can do x log of 2 plus 3x plus 1 log of e. Now log of e is equal to 1, so we can cancel that out on the next line and simply write x log 2 plus 3x plus 1 is equal to log of 10. Collecting the logs on the left hand side, on the right hand side, sorry, scratch that. If you factorize out the x, you get log 2 plus 3 is equal to log 10 minus 1, and we can divide to give us x is equal to log of 10 minus 1 all over log of 2 plus 3, and if you write that in the form that they're asking for, you get minus 1 plus log 10 over 3 plus log 2. So A is minus 1, B is 10, C is 3, and D is 2. find out the amount of antibiotic in the bloodstream 4 hours after the dose is given, you must substitute into the equation that you have using the values that are given in the first paragraph. So X, the amount of antibiotics left, is equal to 15 milligrams, so where the D is, multiplied by e to the power of minus 0.2 times by t, which in this case is 4. If you equate this, you get 15 times e to the minus 0.8, and that equals 6.40 milligrams to 3 dp. Part B. Now, when the second dose of antibiotics is given, you can't add the two doses together because they are decreasing at different rates. So we need to use a general equation. X is equal to the sum of two individually decreasing antibiotics, D1 times by e to the minus 0.2 t, and I'm going to put t1 here because the time at which each antibiotic is being activated is different, plus d2 e to the power of minus 0.2 t2. If I substitute in the values that I have, both doses are 15 milligrams, so 15 times e to the power of minus 0.2, and I have 7 hours here because it's 2 hours after the second dose is given is where you're measuring. Now, because it's 2 hours after, you know 5 hours already passed, so a total of 7 hours for that particular dose to be decreasing. That means the second dose must have only been working for 2 hours, so we can fill the rest in, multiplied by 2. If you equate this and simplify it, you should get 13.754 milligrams as stated. Part C asks for the amount of time taken for the antibiotic to reach 7.5 milligrams. If I set the amount of antibiotic known as 7.5 milligrams equal to the equation that I've just constructed, 15 e to the power of minus 0.2, and notice that the time I'm using is going to be t plus 5. The reason I'm using t plus 5 is because the first amount of antibiotics started decreasing after 5 hours more than the second dose did, and we're measuring from when the second dose was administered, so we need t plus 5. The second dose was 15 e to the power of minus 0.2, and this we can just write t because we're measuring from when this dose started. If I start substituting or simplifying all my values, I can divide through by 15 to get a half on this side, and both 15s here vanish. So I get e to the power of minus 0.2 t minus 1 plus e to the power of minus 0.2 t. Now, notice that I can separate out e to the power of minus 0.2 t and e to the 1 because powers add when they multiply, so e to the minus 0.2 t multiplied by 1 over e is the same as what we have above, plus the right hand side, which is unchanged. I can collect all the terms involving t, and actually I can multiply my entire equation by e to make it slightly simpler. I get e to the minus 0.2t plus e times e to the minus 0.2t. If I factorize out the e to the minus 0.2t on the right hand side, I get 1 plus e, which is still equal to e over 2. Moving over here onto the right hand side, if I divide through now by 1 plus e, I get e divided by 2, 1 plus e, is equal to e to the power of minus 0.2t. Now, this power is negative, which means I can express it as a fraction, 1 over e to the power of 0.2t, and the right hand side is unchanged. But I can take the reciprocal of both sides, so I get 2 plus 2e all over e is equal to e to the power of 0.2t. Now I've reached this stage, I can take logs of both sides. So if I take log base e of 2 over e plus 2, notice all I've done is separated the fraction into two parts. That's equal to log of e to the power of 0.2t. Now this is going to come into the front, and log e is going to cancel, and I'll get 0.2t is equal to log of 2 over e plus 2. Therefore t is equal to 5 lots of log of 2 plus 2 over e, which means that in this question a is equal to 5 and b is equal to 2. Question 3. The straight line with the equation y equals 3x minus 7 does not cross or touch the curve with that equation, where p is a constant, which means that if we set those two lines equal to each other, i.e. we have 3x minus 7 equal to 2px squared minus 6px plus 4p, then we need to find values of p such that this quadratic in x does not have any solutions. The reason being is because now we've got a single quadratic and we need to show it has no roots. It's the equivalent of showing that initially the two curves had no intersection points. If I rearrange so that I have a quadratic on the right hand side, I get 2px squared plus x lots of minus 6p minus 3 plus 4p plus 7. I can use the discriminant to determine how many intersection points I have. If the discriminant was greater than or equal to 0, it would either have 1 or 2 intersection points. If b squared minus 4ac is less than 0, however, I know that this curve will not have any roots, therefore it will not have any solutions. So substituting into the relevant points, I get minus 6p minus 3 all squared minus 4 lots of 2p times 4p plus 7. And I'm going to set this less than 0. If I expand and collect terms, expanding on the left hand side gives me 36p squared plus 36p plus 9, and on the right hand side I get minus 32p squared minus 56p, and overall this gives me 4p squared minus 20p plus 9 is less than 0. It says hence find the set of possible values of p. Well, if I'm trying to solve this inequality, I need to find the roots with the x-axis. I can factorize this to give me 2p minus 9 multiplied by 2p minus 1 is less than 0. That means the critical values are p is equal to 9/2 or p is equal to 1/2. If I plot these points on a curve, that's 1/2, that's 9/2, and I draw the curve on, then because this is less than 0, I know that I need to be considering things that are underneath the x-axis, i.e. my solution set is for any value of p between 1/2 and 9/2, and the full solution set is p such that p is greater than 1/2, less than 9/2. Question 4 starts by asking you to show that x is greater than 1.7, and it's giving you some information and says that the perimeter of the garden is greater than 40 meters. Well, if you look at this edge and this edge, they make up half the perimeter, because in any cuboid type shape or cubic shape, this length and this length will always sum to give this length, and this length and this length will always sum to give this length, which means that I can create an inequality where I have 4x plus 6x plus 3, and I know that 2 lots of this is equal to my perimeter. To create the inequality, well, if I simplify everything that I have 20x plus 6 is my current perimeter, and I can set this greater than 40 because my perimeter was stated to be bigger than 40. I can rearrange to find x on its own, so 20x is greater than 34, giving x is greater than 1.7. Given that the area of the garden is less than 120 meters squared, form and solve a quadratic in x. Well, before we worry about the inequality, let's find the area. Now, this shape here, I'm going to take away from my complete rectangle. That means I have 4x multiplied by 6x plus 3 minus, and if I look over here, I know this length is going to be 4x plus 2, and this length is going to be 2x, so I can take the multiple of these two away to get my total expression for my area. So I have minus 2x times 4x plus 2. Now this is equal to my area, and I can simplify this to say that my area is equal to 16x squared plus 8x. The inequality can now be formed by saying that this expression, 16x squared plus 8x, is less than 120. And to solve this, I can start by dividing by 8. So 2x squared plus x is less than 15. If I rearrange and factorize, I get 2x minus 5 x plus 3. Now to solve this, it's just like any other inequality. I need to find the critical values, so that occurs at x is minus 3 and the other one at 5/2. if I draw my curve in, it's not very accurate, but it doesn't have to be, then I know I'm considering things underneath the axis. So x is between -3 and 5/2. Now x is a length, so we can't have x being 0 or less, so x is greater than 0 and less than -5/2. To state the range of the possible value of x, well, I've got two inequalities. I have x is between 0 and 5/2, and x is greater than 1.7. Now I'm going to stack these so all my signs are pointing in the same direction, and as you can see, this here is more overpowering than the 0. That means 1.7 is less than x, is less than 5/2 or 2.5. Question 5 is quite short, but if you look at your formula booklet, it actually helps you quite a bit by stating the following. For sine theta, where theta is small, we can assume that sine theta is roughly equal to theta. Similarly, for cos theta, we can assume that cos theta is roughly equal to 1 minus a half theta squared. Now, use the small angle approximations to find the approximate value of the following. Well, if I substitute in 1 minus, now I have cos 4 theta instead of theta, which means that wherever I see theta in my formula, I can replace it with 4 theta, like that. I can do the same with sine theta, and I get 2 theta multiplied by, well, I have 3 theta in place of theta, so I can write 3 theta. If I equate this, I get 1 minus 1 plus a half times 4 theta squared, which is 8 theta. This is all divided by, whoops, I forgot the squared. This is all divided by 6 theta squared, which gives me 8/6, which is 4/3. The 2 theta squareds cancel, so I get an answer of 4/3. Question 6 asks you to find two possible values for an angle that's unknown in a triangle. If I start by sketching the triangle and writing in all my known values, it can help me determine what formula I may need to use. Now, the triangle ABC states that this side is length 16 and the side AC is length 13. ABC has angle 50, that means this is the angle that's 50, and we're trying to calculate the angle BCA, so this is the unknown angle. Now, if you can see, you've got two sets of angles with two sets of opposite sides, which refers to the sine rule. So sine A over A is equal to sine B over B. If I substitute in my values, I get sine 50 divided by 13 is equal to sine x divided by 16. Rearranging for sine x, I get x is equal to 16 sine 50 over 13, and so x, if I take arcsine of both sides, I get x is equal to 70.5. Now, there are two ways of doing this. I prefer the cast method. I will show you the graph method, but to find other angles, I know that if my angle is 70.5, then going from A to S means I'm reflecting in this axis, this vertical y-axis. So my other solution must be found when flipping it along this line, which gives this size to be 70.5. So my other value should be 180 minus 70.5, which is equal to 109.5. 70.5. That means my two values for x are equal to 70.5. Obviously don't round until the final step, or 109.5 degrees. If I were to use the graph, well, if I plot my sine graph from 180 to 0, then if I find 70.5, it's going to give me this particular value on sine. That means to get the same value, I can read across and know it's symmetric across 90. That means it's the same as 180 minus 70.5. Also, if you're wondering why the triangle does have two different solutions, well, if I rotate the triangle a little bit, I can help you see this. If that's A, that's B, this can be C. If that's 16 and this is 50, then this could be one of the potential places where this line of at 50 degrees meets this length of 13. But there's another solution here which gives you these two possible values for x. Question 7. The first part of the question asks you to prove that sine 2x minus tan x is equivalent to tan x cos 2x. Now, the best way to approach any one of these proof problems is to pick a side. Now, I'm going to pick the left-hand side. To prove it accurately, you must rearrange the left-hand side until it looks exactly like the right-hand side. Now, as you'll see, there are not too many steps with this one, but for some of them, the answer might not be so obvious, in which case simplifying the right-hand side actually gives you a temporary endpoint in which you can undo your steps to work out the rest of the proof. All that means is, if you need to, work both sides, but make sure the answer that you show is one side completely transformed into the other. On the right hand side, it's got tan x times cos 2x, and I can't see any great starting point. So I'm going to convert everything I have into sines and coses. So sine 2x becomes 2 sine x cos x minus sine x over cos x. Now, if I look ahead to my answer, I can see that tan x is multiplied by cos x. Well, multiplied by cos 2x, which means overall I'll have a cos x on the bottom. So I'm going to combine everything into one single fraction where I get sine, two lots of sine x multiplied by cos squared x minus sine of x, all divided by cos x. If I factorize out the sine from the numerator, I get sine 2 lots of cos squared x minus 1 all over cos x. I'm going to work over here on the right. Sine x over cos x, well, that's equal to tan x. And I know that 2 cos squared x minus 1 is equal to cos 2x. And I have the result that I'm looking for. So I can say equals to right hand side. So sine of 2x minus tan x is identical to tan x cos 2x. Part B, well, typical to most trig questions where you have a part B is that part A is really, really important, which means that the result that you made and found in part A is going to be quite important. If I rewrite out my equation sine 2x minus tan x, I know that's equal to tan x cos 2x. And so 3 tan x sin x is going to be equal, using the identity above, to tan x cos 2x. If I take everything to the left hand side and factorize out tan x, I get tan x brackets cos 2x minus 3 sin x. That means I have two solutions where tan x is equal to 0, or where cos 2x minus 3 sin x equals 0. The left hand side is already solvable, so let's put that on hold for now and focus on the right hand side, where cos 2x minus 3 sin x is equal to 0. If I use the other form of cos 2x, I can say cos 2x is equal to 1 minus 2 lots of sine squared x. That means 1 minus 2 lots of sine squared x minus 3 sin x is equal to 0. This is a quadratic in sin x, so I have, multiplying by minus 1 and rearranging, I get 2 lots of sine squared x plus 3 lots of sine x minus 1 equals 0. Now, if I use the quadratic formula, I get sine x is equal to minus b plus or minus b squared minus 4ac all square rooted, everything divided by 2a, and if I sub in my values, I get minus 3 plus or minus b squared, which is 9, minus 4ac. I've got a minus times a minus 1, so plus 1 times 2 times 4, which is 8, all divided by 4, which is equal to minus 3 plus or minus root 17, all divided by 4. Now, to solve this, well, minus 3 minus 17 over 4, sorry, minus 3 minus root 17 all divided by 4 is actually smaller than minus 1. So it doesn't have a solution, but the positive root does. So sine x equal to minus 3 plus root 17 over 4 does have a solution. We can use this to calculate x to be 16.3. Now, similar to the diagram I drew earlier, the cast diagram, if I write out cast, well, I'm going to draw on my angle as 16.3. It doesn't need to be accurate. I'm working in sine. That means to go from A to S, I need to reflect in this vertical y-axis. So my other solution is here, with this angle being 16.3. That means my solutions are x is equal to 16.3, 180 minus 16.3, and so on. But these are the only two solutions that are in the range. So it's this one and this one. If you were to use the graph, well, I'll show you that quickly. But I have that to be 180, that is 0, 16.3 is somewhere here, and it gives me this particular value, which can be extended to find this other value, which is 180 minus 16.3. Otherwise, we can write which is equal to 163.7. Now, let's go back all the way to the start when I said that tan x will have some solutions. Well, if I draw the graph of tan x, then I know that tan x will have solutions at every 180 degrees. So x not only equals 16.3 and 163.7, but it also equals 0 and 180. We can't include 360 because this inequality here is strictly less than, so 360 cannot be a solution, but the remaining four are. Question 8 asks you to put this particular trigonometric expression into the harmonic form r cos 2 theta minus alpha. Now, with any trigonometric equation where you're using the harmonic form, you should always be expanding this using the formula for cos. So this expands into r cos 2 theta cos alpha plus r sine 2 theta sine alpha. Now, in order to do this correctly, you should be comparing the coefficients. Now, you have a cos 2 theta here, so that means this r and this cos alpha should be equal to this 4 here. So we get r cos alpha is equal to 4. We can do the same thing with sine. If we compare sine 2 theta's coefficients, we have sine alpha and this r here is equal to 2, and we can create a new equation, r sine alpha is equal to 2. Now, to find the values of r and alpha, well, if I divide equation 2 by equation 1, I get the following. I get r sine alpha all divided by r cos alpha is equal to 2 over 4, which is the same as saying that because these two r's cancel, I get tan alpha is equal to a half. And we can use that to calculate alpha to be 26.57 to 2 dp. To calculate the r's, well, we need to use the identity sine squared plus cos squared is equal to 1. If I square equation 1 and add it to the square of equation 2, I get r squared cos squared alpha plus r squared sine squared alpha is equal to 4 squared plus 2 squared. If I factorize out r squared, I get sine squared alpha plus cos squared alpha, which we know to be 1, equal to 4 squared plus 2 squared, which is 20. That means r squared, which is all that's left on the left hand side, is equal to 20, so r is equal to the square root of 20. To solve part B, we need to use, once again, that idea of repeating what we've done in part A. We need to use that result to help us solve for part B. If I immediately convert into the harmonic form, I get root 20 multiplied by cos of 2 theta minus 26.57. I can set that equal to 1. If I rearrange, so 1 over root 20 is equal to cos of 2 theta minus 26.57. I can use arc cos to say that 2 theta minus 26.57 is equal to my first solution, which is at 77.079. Now, I'm going to pause here because this is a very common error, but not finding enough solutions. Let me show you how to make sure you've checked for enough solutions. If the range that you need to search for is between minus 90 and 90 not inclusive, then to get from theta to 2 theta minus 26.57, I can multiply everything by 2, and you should be able to see that step by step we're getting to a range involving 2 theta minus 26.57. If I now take 26.57 away from everything, I get 2 theta minus 26.57. Well, on the left hand side I get minus 180 minus 26.57, and on the right hand side I get 180 minus 26.57. So the range of results that we actually need to look for 2 theta are between 200 minus 206.57 and positive 153.43. And we need to now look for the results in these two ranges. So minus 206.57, 253.43, and that can be a way to make sure that we've covered every single solution. If I draw out my diagram again, and I know that this angle is 77, I'm not going to write out the full thing, and I write out cost. Well, this time we're working in cos, as you can see here. So to go from all to cos, I need to flip in the x-axis. That means all my other solutions are found using this line. If I do this simultaneously using the diagram, well, if this is 90 and this is minus 90, then any solution I find here can be immediately translated over here to be found as minus 77. So we've immediately got two values that are in our range. We've got 2 theta minus 26.57 is equal to 77. I'm going to put 0.1 because it asks for one decimal place. Obviously you should round at the end of your question. So that's one solution at 77.1, and then there's another solution at minus 77.1. So there's one solution here and one solution here. Now I'm going to go around to make sure if I have any extra solutions, and if I stop about here, I've reached 153, so I know there's no more solutions that way. If I go in the negative direction and I go here, I've reached about minus 206, so I also know there's no more solutions. So the only two solutions are these two. Now if I add 26.57 and then divide by 2 for both of them, I get 77.1 plus 26.57 divided by 2, or minus 77.1 plus 26.57 over 2, to give me my two values of 51.8 or minus 25.3 degrees. It says now for part C, given that k is a constant and the equation has no solution, state the possible values of k. Well, if you think about the graph that we have, g of theta, we've expressed it as root 2 of some cos function. And I'm just going to write cos function here because it doesn't actually matter what is inside the function, because no matter what angles you put in, the maximum value that this cos function is ever going to reach is root 20. The reason it's root 20 is because normally your cos graph goes between 1 and minus 1. So your cos graph here goes between 1 and minus 1. But because we've got root 20, lots of it, then the maximum that this graph is going to go between is somewhere between here, which is root 20, and down here, which is minus root 20. If I I were to continue this graph to show what it would look like. It doesn't actually matter how thin, how wide, and if it's translated or not. All we need to know is that the max is at root 20 and the minimum is at minus root 20. It says that the solution, that the equation g of theta equals k has no solutions. That means that you can't ever put in an angle which will give you an answer that equals k. As k has a maximum value of root 20 and a minimum value of minus root 20, well then k must be strictly greater than root 20, or k must be strictly less than minus root 20. This is enough. If you did want to put it into a set, you could say that it's a set of k such that k is greater than root 20 union with a set of k such that k is less than minus root 20. The important thing to note is that for any harmonic form r cos theta plus alpha or r sine theta plus alpha, etc., that the maximum and the minimum is always found by r. So the maximum is r and the minimum is minus r.